Hello everyone! Welcome back. I've really missed you all, and I want to start by giving a big thank you for all of the support. It means so much to have you all here, and there was so much more support than I could have ever imagined, given the drama. Today's video is going to be a lot of fun and interesting. We're going to break down Thor's code for Heartbound, how it works, what the thought processes might have been, and how it can still be improved on. And here's the fun part. I'm going to suggest things that haven't really been brought up before, while also keeping in mind the restrictions of GameMaker in 2018 when the code was originally written. So this isn't just about what went wrong. It's about what was actually possible in that environment, and what may have inspired the way that the code was written in the first place. And yes, there will still be a lot to learn from. Now I know there's been a lot of noise and drama surrounding Thor. Some of it is fair, but a lot of it seems to be blown out of proportion too. That's kind of what happens when you're in the spotlight. The bigger you are, the harder you fall. Here's what I've noticed about Thor. He tends to over-explain things. A lot. Sometimes to the point where it overshadows the core message, or gets lost in the too long didn't reads. And honestly, I get it. I have a habit of over-explaining myself too. Just check out my YouTube comment section. I'm extremely guilty of writing a 3-paragraph answer to a 1-sentence question. It's the engineer's curse. We can't just say what we did. We want to explain the why and the how, and sometimes give a mini lecture along the way. It's not about overthinking, it's about wanting people to really understand the process. It's actually pretty common for engineers in general. We want people to understand not just what we did, but why we did it. But can you really blame us? It's our job to find every possible thing that can go wrong and fix it. And in a way, this ties back into how we approach code as well. In a code review, the goal isn't to jump in with questions like, "What the were you thinking?" That doesn't really help anyone. But apparently, CJ never learned this lesson. That's why I'm convinced he's never actually been on a team in his life. A better question to start with is something more like, what was your thought process behind this? That way, you leave room for discussion, for compromise, and learning. Asking questions is fine, but doing it with an intent to better the project and code is important. Because code isn't just about output. It's about problem solving, teamwork, and communication. Flexibility and open minds are way more important than being rigid. Or, to put it another way, just don't be a jerk. Especially when you are on a team. That's why I find this breakdown valuable. Even if the code isn't perfect, there's still a lot we can learn from it. Especially once you factor in the quirks and limitations of GameMaker in 2018, that many people have forgotten about. So let's dive in and see what we can uncover together. This code review will start by looking at the good aspects of the codebase, talking about the functionality of the code and what it does, and suggesting possible ways to still improve on it. The goal of this review is to offer positive feedback and suggestions to anyone who may share similar aspects in their own code, and to understand and build upon what is already there with minimal code restructuring. Next, we'll move on to the problem areas, diagnosing the limitations that Thor may have had to work with at the time, while exploring the potential thought processes when writing the code in the first place. Then, we will discuss practical ways to improve the code, both in the past and in the engine today. And yes, this time all of my suggestions have been tested in the exact version the code was written in. Because making suggestions before you understand the engine, what is possible, or the author's goals, is both foolish and useless. Don't waste your time. Anyone who suggests you don't fix it, you replace it, is not a professional, because major restructuring changes like that would either be impossible, as we've seen, or set the project back unnecessarily, and they are scarcely an available option. In most cases, you can always refactor code to make it more maintainable without restarting the whole damn thing. Major restructuring suggestions are better suited as lessons to use for the next project or the next system. But first, a few corrections to make from the previous video. I stated that you can create functions in the creation event of objects. We discovered this was incorrect for that version. While you can still do this in the current version of GML today, this feature wasn't available until quite a few versions later. So, while it's still useful to know today, it would not have been useful to Thor in the past. Likewise, we found that ternary operations also didn't exist in that version, which is a shame. You see, I am willing to admit when I'm wrong, because all I care about is sharing accurate information, unlike some people. I would also like to note that any numeric literals in the decompiled code are very likely the result of macros being converted at compile time into their literal values. We have no way of telling if macros were used or not because they don't actually exist in the code. Another irritating discovery I have found while reliving the torments of the past working in this older engine version. Arrays don't have bracket initializers. You can't assign a list of values like you would be able to in the current version. You can pre-allocate a fixed size array, but you are expected to assign the values element by element. You can use a loop for this, but we have already discussed what the true purpose of these lines was, and that Thor does in fact initialize every value in a loop up to the index of 1000 at the top of all of these assignments. Isn't it interesting how nobody else seems to have mentioned this fact? One thing I found quite interesting in my exploration of this project, that nobody else seems to have talked about, Thor actually has a little microtext preprocessor hidden in his dialogue system to do all those fancy text effects, which is rather impressive and unexpected to see in a project of this size. Here, he's written a tokenizer into his dialogue text, which, for my non-technical audience, is basically scanning through some of the text and categorizing parts of the text with labels. This is what any color-coded text editor is doing behind the scenes, and also one of the steps a precompiler does. This allows him to apply per-character effects to his dialogue text, which is more than most people's first or second projects tend to do. For that matter, most indies don't bother adding multiple translations into their game, or design their color scheme with color blindness in mind either. This shows some of his QA experience and some technical knowledge that most beginners probably shouldn't have. I will step you through briefly what this code is doing and then show you its effects in the game. First, he starts by looping through every character in the current message. That's this while loop here. If the current character matches one of the special tokens, it will start consuming and storing all of the characters after until it reaches what's called a token terminator. In this case, that's the underscore. Once we have terminated the current token's inner loop, we cast the current token string into a real number value and store it for later. He does this for each token type, categorizing them into their own respective styling tokens. This is fairly normal for text preprocessing, and regular expression works very similar to this. For every character that is not part of a token, he applies the active style as defined by each preceding token to the next characters. That's this default case here. You can see he also removes the voice chirp from characters that are spaces. All of this essentially lets him apply rich text-like styling to his dialogue. So how can we improve on it? Well, one method we can use is we can take advantage of a pre-incrementer and pre-increment the value of count before passing it in to get the next character. This can reduce some of the redundancy inside of that while loop. To show you the effect of each token in the game, I'll be taking advantage of this hilarious piracy screen that he's set up here. Say what you want about the guy, but he's got a sense of humor at least, and he's given me the perfect way to showcase this functionality for you all. Now let's take a look at Thor's minigame combat system. Thor's combat system is built to interact with his dialogue system. Here, he has each of his combat minigames as a controller object in the scene, and each minigame handles its own logic when it is the active game. Once that game is done, it hands control back to the controller object to select the next game. If the randomly selected sequence of games runs out, he generates a new list of games with no repeats. If the combat round is either 5 or 10, it overrides the current game's behavior to show some dialogue and set some flags. This shows he knows some amount of separation of concerns as each of his systems handle themselves. Thor does have a lot of alarm events. The names of these alarms are not compiled because the description tag is a comment, so we can't see what he's named them. Alternatively to using alarms, you can do what I would do and just make your own well-named timers in the step event, which is honestly, in my opinion, much more flexible and more what I'm used to. Notice also the use of naming conventions that groups related variables so that you can find them a lot more easily in the autocomplete. This is a good practice to get used to. This also keeps all of the timer-based code in one event that can call other overridable, well-named user events, and it gives you a named timer variable to work with. This is also a good example of when you should make a variable for constants and why. Deep nesting usually isn't a great practice. It's something you'd often see in beginner code, but even experienced developers fall into it sometimes, especially in web development. After working in this older version of the engine myself, though, I am willing to give Thor a partial pass. The usual fix, guard clauses and early returns, doesn't work here the way that you would expect. Returning early doesn't just exit the current script. It ends the entire event, skipping any remaining scripts tied to it. That's absurd, but it's how this version works. Normally, you would think of these event scripts as separate functions, at least with their own scope. But in this engine, they're all merged into one giant block of code, sharing the same scope. So, if you return from one, you exit everything. That design choice alone almost forces developers into deeper nesting. There are still ways to reduce the clutter. For example, if you have two stacked if conditions with nothing in between them, you can merge them with an AND. You can also use temporary Boolean variables to name logic checks, which also can improve on readability. Another trick, now that we know user-defined events exist, Thor could move his dialog switches into a user event. That way, the parent object just calls the event, and the messy logic lives in one place instead of being duplicated everywhere. Let's talk about the elephant in the room, those deeply nested switches. Now, why use such big switches at all? I have no way of knowing if Thor knows this, but compilers do actually optimize larger sequential switch statements like this with something called a jump table. Think of it like an address book. Instead of checking each case one by one, the program jumps straight to the right case in program memory. That makes the switch more efficient than a giant if-else chain. The trade-off is readability. Hundreds of cases with magic numbers are hard to maintain. But back then, Thor didn't have function pointers or modern scripting tools. This is Thor's most egregious, longest, and deepest switch statement that I could find with 150 cases. Coding Jesus and some other creators said that Thor has 1,000 deep nested switch statements. This is actually not true. Thor simply uses case 999 as an exit state. This was very misleading of them, in my opinion. Once you realize it's mostly just repetitive code, it's fairly simple to refactor. With a regular expression and using a little bit of brainpower, I was able to turn it into this rather quickly with little effort. This is much easier to understand what's actually going on, and the jumps stick out much better in my opinion. It's just a giant finite state machine. Each case explains what message ID to show in the localization array, and what case to go to next. And they also have the option to add extra logic or overrides. This allows him to place any message in any order, even if it's not sequential in the array, and you can even repeat messages at different points in the sequence. It's flexible and easy to work with. You just need the story handy to figure out where you are and what is being said. Since this state machine is primarily sequential, we can assume that the next step is always going to be the current step plus 1, and only override it where we need to. These overrides would be equivalent to a goto in C or a jump in a RimPy script, and you can even make variables for labels if you wanted to. At the end, I put the common code that was called in nearly every case and created an option to override the behavior if needed. Here I have also created some branching variables that describe what the branch decision was. For now, they are named discretely, but you get the idea. And I have also created some comments that describe the go-tos and where they came from. These combined give a more visual representation of the story branches and also shows the use of his global story array. Now, comments don't compile, so we won't see them in the decompiled code, but I bet you he does have them. And if Thor were to put these state machines into user events, they could be self-contained and called by a parent script, which would further reduce the nesting and the code repetition. So now you might be asking, why did Thor do it this way? Well, we already know that the function keyword and the callbacks don't exist, so he created his own using a state machine. He might have also gotten inspiration from Undertale, as they have the same system, and he has a short on it.
You don't need to be an amazing programmer, Jen. Do you know why? Because Undertale exists. Undertale is one of the worst programmed things that I have ever seen. It is horrible. There are rooms that have hundreds of if statements in a row checking the same value, and then it sets the value to 0 and then checks it again. All of the dialogue in all of Undertale is in a single switch case statement, thousands of cases long, for the whole game. But you never know that, and it doesn't matter, because the player doesn't care, and the player would never know. That's it. Go make games.
And if he's never felt the need to modernize to new engine features like structs, because it causes him no harm or no issues, then that's fine. This is actually deceptively easy to work with once you have the full story, literally and figuratively. As I was reviewing the code, I realized something. Thor may have kept the repetition on purpose. The story itself is the documentation. Each case directly maps to a line of dialogue. So when he wants to change the story, he just finds the matching case with the correct line and then edits it. In other words, Thor's switches are a workaround for features the engine didn't have, like go-to labels and or callbacks. Funny enough, RenPy, a popular visual novel engine, still uses go-to labels today for branching dialogue. Thor basically built that system from scratch. Now, there are more modern ways to do this. For example, you can use an observer pattern, where the system listens for dialogue lines and or triggers functions when they're needed. Adding function tokens directly into the dialogue so that the data itself can trigger code events without giant switches. He also already has a text preprocessor that he can use for this. These methods reduce repetition, scale better, and keep the link between the story and code, but given Thor's tools at the time, his solution made sense. And since it works without breaking, he probably never needed to change it. The upside of these changes: Thor could refactor newer objects with these improvements and gradually replace older code, but since everything already works in the exact same way, there really is no real need to go back and rewrite it all. Ultimately, the things that could be improved on, as I said, were vastly over-exaggerated by people who did not understand the problem space and limitations of the engine at the time. And most of the actual problems had simple solutions that could be gradually adopted and improved on over time, rather than starting completely over. And no, I still don't believe that this will slow down development, because every issue can be solved with a little bit of refactoring. Once again, magic numbers are not all numbers you don't understand, and it's very important to understand the problem space, the thought process, and the limits before making judgments on the way that code is written. Never make a judgment on the person who wrote the code, because they are not their code. There will always be something to clean, because you're also limited to your current knowledge at the time. It's not worth obsessing over clean or efficient code if the result of those obsessions stalls your progress. But you should always at least try to consider how easy the code will be to work with, and to work towards building a better tool belt to make it easier for yourself and or others to work with in the future. I do think that Thor showed some level of advanced programming experience with some of the concepts that he seems to understand, at least the base level. But ultimately, I think most of his experience was very likely just in QA, puzzles, and cryptography, as the code and the projects reflect that very much. This game's real puzzles are in the ARG. I also feel like he has never actually needed to upgrade or refactor the code very much, because it's actually pretty easy to work with when you have the full story. But whether or not he chooses to take some of this advice for this game or the next, there was still a lot for everyone else to learn from in this code. If you enjoyed watching or learned anything, be sure to leave a like and observe that subscribe button and be notified in the event that we publish the next video. Feel free to also comment on any future video topics or questions that you would like for us to cover. If there is anything else that can be said about this code and how to improve it, we might post a follow-up video. Or, if anyone else would like a proper code review done for their own code, feel free to send in the request.